calculus describe motion? Why do differential equations govern everything from atoms to galaxies? An electron doesn't know calculus, it doesn't solve equations, it doesn't compute integrals, but its behavior follows equations, perfectly, exactly, always. How? Why? This question haunted me my entire life, and I never found a satisfying answer. Nobody has. But I learned something profound trying to answer it, something about the nature of reality, the nature of mathematics, and the relationship between them. Let me share what I discovered, what I struggled with, what still amazes me. Start with a simple observation, a fact so obvious we barely notice it. Nature follows rules, precise rules, mathematical rules. Drop a ball, it falls. How fast? Exactly according to equations. Not approximately, not roughly, exactly. Charge flows through a wire. How much? Exactly according to Ohm's law. Precise, mathematical. Light bends through a lens. Where does it focus? Exactly where equations predict, every single time. No exceptions, no approximations. Perfect mathematical precision. This is strange, deeply strange. Why should reality obey human mathematics? Why should equations we invented in our minds match what happens in the world? Eugene Wigner wrote a famous paper about this. The unreasonable effectiveness of mathematics in the natural sciences. Unreasonable. That's the key word. It's not reasonable that math works so well. It's miraculous, mysterious, unexplained. Wigner gave examples. Mathematical concepts developed for pure theory, abstract, disconnected from reality, later turn out to describe nature perfectly. Complex numbers, invented for solving equations, pure mathematics, no physical meaning. Then quantum mechanics comes along, and it turns out electrons are described by complex numbers, wave functions, complex amplitudes, essential, fundamental. How did mathematicians invent the right mathematics before physicists needed it? Coincidence? Too many coincidences. Group theory, abstract algebra, symmetries, pure math, beautiful but seemingly useless for physics. Then particle physics discovers symmetries are fundamental, gauge symmetries, Lie groups. Everything Wigner classified particles using group theory. Perfect match. The mathematicians had already worked it all out, decades earlier, for completely different reasons. Why? How? This is the mystery Wigner pointed to, the unreasonable effectiveness. Mathematics works better than it should, better than we have any right to expect. And I felt this mystery deeply. Every time I derived an equation and found it matched experiment, every time I predicted something using math and nature agreed. I remember one particular moment, 1948. I was working on quantum electrodynamics, trying to calculate the magnetic moment of the electron. The calculation was brutal. Pages of integrals, Feynman diagrams, complex numbers. Infinities I had to remove through renormalization. Took me weeks, made mistakes, started over, finally got an answer. The prediction, electron magnetic moment should be slightly different from the simple value, by a tiny amount, about 0.1%. I was nervous. This was a bold prediction, based entirely on mathematics, on my new formulation of quantum field theory. If it was wrong, my whole approach might be wrong, years of work possibly worthless. We tested it, measured the electron's magnetic moment, precisely, carefully, and it matched, exactly, to every decimal place we could measure. I sat there, staring at the numbers, shaking slightly. How? How did my mathematics, my human symbols on paper, my invented formulas, predict what an electron would do? An electron that doesn't know calculus, doesn't know Feynman diagrams, doesn't know mathematics at all, but it behaves exactly, precisely, perfectly, according to my equations. That moment, that realization, that's when the mystery hit me. Fully, deeply, viscerally. It was too good, too perfect, too mysterious. Why does the universe speak mathematics? Why doesn't it speak some other language, or no language at all? I don't have a complete answer, but I have thoughts, observations, patterns I noticed. First, nature uses principles of economy, optimization, efficiency. This is everywhere in physics, and it's deeply mathematical. The principle of least action, one of the most profound principles in all of physics. A particle moving from point A to point B doesn't take just any path. It takes the path that minimizes the action, a specific mathematical quantity. Why? Nobody knows, but it does, always, perfectly. light traveling through different materials. It takes the path that minimizes travel time. Fermat's principle. Why? It doesn't know calculus. It doesn't compute, but it finds the optimal path. Every time, think about this, really think about it. A photon enters glass from air, has to reach a point on the other side. Infinite possible paths. The straight path through air and glass, not optimal. Too much time in slow glass. A path that's straight in air, then straight in glass, not optimal either, unless it's at exactly the right angle. The actual path bent at the interface, at precisely the angle that minimizes total travel time. How does the photon know which angle? It doesn't calculate, doesn't try different paths, doesn't compare times, but it chooses perfectly, every time, the mathematically optimal path. In my path integral formulation, I explain this. The photon tries all paths. Each path contributes an amplitude. The paths interfere, and the path that contributes most, the one where nearby paths have similar phases, similar actions. That's the minimum time path. So in quantum mechanics, the photon does try all paths, and the interference automatically selects the optimal one. Beautiful, elegant, mathematical. But it still doesn't answer why. Why does nature work this way? Why this particular mathematical structure? This optimization, this economy, is mathematical, inherently mathematical. Minimum, maximum, optimization, these are mathematical concepts, and nature uses them everywhere. I once said nature uses only the longest threads to weave her patterns. What did I mean by this? Not longest literally, most fundamental, most economical, most elegant. Nature doesn't waste, doesn't complicate unnecessarily, chooses the simplest, most elegant solution, and simple, elegant. These turn out to be mathematical properties. The equations that govern nature are beautiful, symmetric, economical, not arbitrary, not complicated. Maxwell's equations, 4 equations, describe all of electromagnetism, all of light, all of electricity and magnetism. 4 equations. Elegant, symmetric, beautiful. Why 4? Why not 40? Why not 4,000? Because nature is economical, uses only what's necessary, nothing more. And economy is mathematical, minimum principles, symmetries, conservation laws. Noether's theorem shows this perfectly. Every symmetry corresponds to a conservation law. Time symmetry, energy conservation, space symmetry, momentum conservation, rotation symmetry, angular momentum conservation. Mathematical symmetry equals physical conservation. One-to-one correspondence, perfect. Why? Why should symmetry, an abstract mathematical concept, correspond to conservation, a physical fact? Nobody knows, but it does, always. This suggests something deep. Mathematics isn't just a description we impose on nature. It's somehow built into nature, fundamental to it. But here's the question that haunted me. Does nature really use mathematics? Or do we just describe nature using mathematics? In other words, is mathematics discovered or invented? If discovered, it exists independently of us. Nature is mathematical. We just find the equations that already govern reality. If invented, mathematics is our creation, a language we made up. And the fact that it describes nature is what? Coincidence? Selection bias? I struggled with this my whole life. Never reached a conclusion. Sometimes I felt mathematics must be discovered. The equations are too perfect, too exact, too universal. I remember a student asking me once, bright kid, Caltech, after a lecture on quantum mechanics, Professor Feynman, do you think mathematics exists independently of humans? I thought about it, paused, said, ask me an easier question, like the meaning of life. He laughed, but I was serious. This question haunted me. An electron in my lab behaves the same as an electron across the universe. Same charge, same mass, same equations. How would that work if equations were just our invention? How would electrons in Andromeda Galaxy know to follow our human mathematics? They don't know about humans. Never heard of calculus. Don't care about differential equations. But they follow them. Exactly. Perfectly, always. This suggests the math is real, built into reality, independent of us. No, the math must be real, objective, built into reality. But other times I thought, maybe math is invented, a tool we created, and it works because we only apply it where it works. We find patterns, regularities, and we invent mathematics to describe those patterns. We don't try to use differential equations to describe human emotions, or love, or consciousness. Why? Because math doesn't work there. So we only use it where it does work. Selection bias. We see math everywhere in physics because physics is the study of things that are mathematical. Things that aren't mathematical we don't call physics. We call them something else. Maybe nature isn't mathematical. Maybe we just focus on the mathematical parts. But that doesn't feel right either, because the mathematical parts are so fundamental, so basic. Motion, force, energy. These aren't obscure phenomena. They're everything. So maybe both are true, in some strange way. Mathematics is a language we invented, but the patterns it describes are real, objective, universal. Like how English is invented, but the things English describes are real. Equations are invented. But what they describe, the relationships, the patterns, those are discovered. The map is not the territory, but the territory has structure, and our map reflects that structure. I don't know if this resolves anything, but it's how I came to think about it. Here's another angle, another way to think about the mystery. Maybe the question itself is wrong. Maybe asking why does nature obey mathematics assumes too much. Perhaps nature doesn't obey mathematics. Perhaps mathematics is our way of capturing regularities. Wherever there's a pattern, a regularity, a consistency, we can create mathematics to describe it. And nature has patterns. Lots of them. Deep patterns. Universal patterns. So of course mathematics works, because mathematics is what we call the description of patterns. It's like asking why does nature obey language? Nature doesn't obey language. Language describes nature. But this still doesn't explain why the patterns are so mathematical, so precise, so exact. A ball falls. We can describe it with equations, but why does it fall the same way every time? Precisely, mathematically, why isn't motion chaotic, random, different each time? The consistency, the regularity, the lawfulness, that's the mystery. And that mystery remains. Even if we say mathematics is just description, I spent my life working with equations, deriving them, using them, teaching them, and the more I worked with them, the more mysterious they became. Not less mysterious, more mysterious, because I saw how perfectly they worked, how exactly they predicted, how universally they applied. I derived quantum electrodynamics, my Nobel Prize work. The equations predict electron behavior to 10 decimal places. 10 decimal places. Perfect agreement between theory and experiment. That's not approximate. That's not rough. That's exact. How? Why? An electron doesn't know my equations, doesn't compute Feynman diagrams, doesn't integrate over paths, but it behaves exactly as if it does. Exactly. This amazed me, still amazes me, always will. The path integral formulation I developed, sum over all possible paths. Each path contributes an amplitude. I derived this mathematically. Pure mathematics. Integrals, complex numbers, action, and it works. Perfectly. Electrons actually behave as if they take every path and sum the amplitudes. How do they know to do that? They don't. They can't. They don't have brains, but they do it anyway. The mathematics describes what happens. Exactly. This is the mystery. This is what I never explained. What nobody has explained. Why does the universe run on mathematics? Why is reality computable? Why do equations work? Maybe because the universe itself is mathematical. Not that it uses mathematics, but that it is mathematics. Patterns, relationships, structures, that's all mathematics is. Abstract patterns and relationships. And maybe that's all reality is too. Patterns of energy, relationships between particles, structures in space-time, not things that obey mathematics, but things that are mathematics, made of mathematics. This sounds mystical, but maybe it's true. Maybe asking why nature obeys mathematics is like asking why circles are round. They just are. That's what a circle is. Maybe reality is mathematics. That's what reality is. Not separate things, the same thing. But even this doesn't fully satisfy me, because mathematics can describe many things that don't exist. I can write equations for particles that don't exist, universes that aren't real, physics that doesn't happen. So why does this particular mathematics correspond to this particular reality? Why these equations and not others? Why these patterns and not different patterns? Selection? Anthropic principle? Because we're here to observe them? Maybe, but that feels unsatisfying too. The mystery remains. Deep, fundamental, unresolved. I, Richard Feynman, worked with mathematics and physics for 50 years. The deepest mystery wasn't quantum mechanics, wasn't the origin of the universe. The deepest mystery, why does nature speak mathematics? I don't know. Wigner didn't know. Nobody knows. But I learned to live with the mystery, to appreciate it, to be amazed by it. Every equation that matched experiment, every prediction that came true, I felt the wonder. Maybe we're not meant to understand why, just that it does. And it does, beautifully, precisely, mysteriously. Nature uses only the longest threads to weave her patterns, the most fundamental, the most economical, the most mathematical. Why? I don't know, but I'm grateful, because those patterns let us understand the universe deeper than we should be able to. That's the unreasonable effectiveness. That's the mystery. That's the wonder. Mathematics works, nature obeys it, or is it, or something. We describe, we predict,